Everyone, as I was just introduced, my name is Sasha, and I am terrible at finishing side projects. I'm never able to finish them. I don't know why, but it's something that I've always struggled with. But a little while ago, I started geeking out on one fixation in particular, which is signage. It's one of those ubiquitous objects that we don't really think about much in general, like chairs. Like I just wanted to create something with signage. And I kind of came across this company called Breakfast in New York that they've been manufacturing flip disc walls for art installations. These are like the kind of signs you would see in train stations for schedules. This is a piece by Japanese artist Masaki Yokobe. I think he's using one of their walls. He doesn't actually document, but I believe he's using one of their walls. It looks like it. And I just thought this was like a phenomenal way of experimenting with the medium. I wanted to make something like this. But the problem is, I have no clue where to start with this. I've never done any fabrication before. The idea of taking on something that is so totally out of my wheelhouse sounded impossible to me. But for the past while, I've been working in project consulting, and in that time, I've started really geeking out on process, helping clients identifying their roadmaps, milestones, and kind of like how to take on projects that really aren't in their wheelhouses. And so I kind of knew that I needed an MVP. And this is a story about how going through that process, I kind of shaped my exploration of the problem and ended up with, something a little unexpected, and something that I didn't really think was a direction I would go in when I started. So the first conclusion was that if I'm going to take on this project, I know that my strengths are in software and not hardware, and that means I need to reduce the hardware factor and maybe learn a little bit about hardware along the way. And after a bunch of research, I came across the idea of using LED modules. These are the kinds of modules that you would find used on electronic billboards in places like Times Square. What happens is they bolt a bunch of these together, and they create these huge displays with them. They're completely modular. It turns out there's some really cool advantages for these from a hardware perspective. For one thing, they're really bright. On average, these panels are about 6,000 nits in brightness. Your average computer monitor is about 300 to 500 nits. So these are somewhere on the order of 10 times as bright as a computer monitor because they need to show up bright in outdoor spaces. And another really cool advantage is that they have a unlimited refresh rate. They basically can update as fast as you want them to update as long as your hardware can support it, which means you're not limited to 60 hertz. If you want to be doing something in 240 frames per second, you could be doing that, which, it's 90 hertz and 144 hertz monitors are becoming popular now. So that's something that, like, if you've experienced one of those, you see that the fluidity of those displays is actually really interesting. On top of that, they're not really high. They don't have a high resolution, which can be seen as like a detriment, but also they have this really great like pixel aesthetic to them that we can kind of play around with. So I kind of really like hooked onto this as something that I could play around with. So just a little bit of background about these panels. They're essentially raw LEDs. They have no real intelligence behind them. As I said, they're used mostly in commercial situations. They're custom installations done by professionals. They're generally controlled by specialized hardware. And they're generally aren't well documented as a result. I don't know if it's just because the manufacturers keep that documentation close to their, chests, or it's just that they don't have any reason to publish that documentation. I think they just generally don't think there's a public desire for it. But they are ubiquitous. You've seen them in, city squares and on the sides of highways. And so an interesting thing is that they're somewhat commoditized, and you can go online and buy these panels for like $10, $20 USD, which is really cheap for something that is, so flexible for us. And the fact that they're commoditized and so low level means that there's actually a decent number of people on the internet playing with them. And in particular, I want to give a shout out to Henner Zeller. He's got this repository going on GitHub, RPI RGB LED matrix. It's a really in-depth repository of code and schematics for circuit boards to control these at a low level using an Arduino or a Raspberry Pi. He's done some really fantastic work, and there's a lot of discussion going on in this GitHub repo. It's a really, really invaluable resource. Um, so here's my plan. I'm going to grab a bunch of these. I'm going to strap them together. I'm going to hook them to a Raspberry Pi. I'm going to figure out a power solution of my own. I'm going to somehow mount them in a cabinet. And I'm going to find a way to make the entire thing interactive. Oh, and because I'm kind of screwing around with this as an experimental thing, I need to find a way to make the software easily updatable. Um, Now that I'm at a crucial point in the project, I find myself taking stock of the things I didn't think I'd need to address or didn't know that I would have to plan for when I began. And I think that's like an interesting part of this endeavor that I kind of want to focus on. Um, you really, really need to be aware of the low level things when you're working with these panels. They don't have any smarts as part of them. You need to be aware of the length of time that you're sending pulses of electricity, and that those match the capabilities of your board, because again, your board is not documented, and these things are measured in nanoseconds. These panels are all multiplexed in really kind of funny, like interesting ways. That it isn't just like you're getting a straight X and Y row and column coordinates. I believe it's to actually prevent the panels from being updated so that they're not really, how would I say this? That there's not artifacts on the screen, so that they're updated in odd ways. And because it's hardware and low level hardware, things generally don't fail gracefully. And I don't know how to debug Hoffman's hardware, so this was like a really new struggle for me. This particular issue, by the way, was because I had a failure in one of my power cables. And it turns out that even if you have your signal coming in but your power not coming in, it turns out all your red LEDs will still light up because they are so low current that they will actually still light up just from the signal alone, in just randomly. It kind of looks like your panel is having a seizure, and the blue and green components won't light up, but your red ones will. Speaking of wiring, these actually have significant power draw requirements. Yes, they're LEDs, but you're looking at, for a 32 by 16 panel, you're looking at 512 LED components, and each one of those has an R, G, and a B subcomponent. So you're looking at typically upwards of 50 watts of draw per panel, which means that when I was building a custom wiring harness, that meant I had to break out a soldering iron, a voltmeter, and a night of research understanding how not to burn my house down, plugging 200 watts worth of undocumented electronics from China into my wall. And like we're all at this point, and we haven't even gotten into the software. We always talk about kind of just doing this little bit and that little bit, but fundamentally, this is a good reminder that we're bad at assessing the true scope of our work. An hour here and an hour there, these things add up. But that saved me because I kind of knew that I needed an MVP. And more than that, I needed a reliable way to understand risk. Enter the known unknowns. So the known unknowns are this tool that I kind of found out first. Funnily enough, I found out about through an old Donald Rumsfeld quote, but it's apparently a reasonably popular tool within the intelligence community used for assessing risk in state actors. I've been using it with clients at work who've had trouble road mapping their projects with pretty great success. And the idea is that rather than assessing the difficulty or the amount of time that we're going to spend on something, we categorize our roadmap in terms of risk certainty. So there's 4 categories. We have the known unknowns. The known knowns. That's things that we know. Fully determined, we understand both the problem and the solution. We have our unknown knowns. Those are things that we don't know yet that we know. That is the things that we are confident we have a determinable solution for, but we kind of need to understand better what that solution is. We have our unknown, I think I missed one of them. If I missed one of them, there's 4. There's the known knowns, the unknown knowns, the known unknowns. Those are the things that we don't know, the things that we don't have a solution for. These things might need a period of discovery. And we have our unknown unknowns. These are the things that we don't know that we don't know. Not only do we not have a full solution, but we aren't able to fully articulate the problem in the first place or how we might approach a solution. I think part of the reason we get stuck on projects sometimes is that we set ourselves up for these little like micro traumas. We attack our known knowns. We know what we can do. And so we just focus on those things without facing the reality of our unknown unknowns at the end of the road. And if you're going to the grocery store without even knowing how to get there, if the grocery store is open or they have eggs, you're going to quickly become debilitated when you're like, I thought this was going to be simple, but it turns out there were a bunch of unknown unknowns that I should have been taking into account. And these are the things that discourage us as we dig further into our side projects. And these are the things that stalemate us. So if we think of our problem space as a set of known knowns and known unknowns, we have a direct set of implied actions for every challenge we see on the horizon. If we know our unknown unknowns represent high risk, we must make them a known quantity or get rid of them. So get rid of them. In particular, I want to give an example from this project, which was the problem of working on control. I wanted to make this interactive. So when it came to the idea of integrating controllers, I kind of had this thought of, okay, so I want to hook up controllers. Do I go USB? Do I go Bluetooth? That means I need to get the drivers installed. Oh, the Linux, the Bluetooth stack is a mess. I'm running everything on Node, so I need to use a Node PID package, but it's not very well supported. And I'm on Raspbian, which has kind of got like this niche driver situation. And I looked into using these Xbox controllers that I had in my closet, and it turns out they don't really work well at all for any PC. They're kind of using their proprietary signal, and it's just like it was a bunch of unknowns that I couldn't. How do I even handle disconnections? What happens then? If I end up exhibiting this thing in public, how do I prevent controllers from getting stolen or damaged? And fortunately, I knew I needed an MVP. And the answer was right in front of me. I'm a software developer. I work on web projects all the time, and I'm already running my panel and all my scripts in Node. I could just spin up an Express server on the Raspberry Pi. So that's what I did. Have users provide their own phones as controllers and communicate via WebSockets. And everything kind of fell into place from there. So this is Obelisk. Oops, make sure it's running. It is exactly what I've been telling you. It's a bunch of these panels on a Raspberry Pi running an Express server on Node. Express is serving a React client application, and that client application is communicating with the server to allow me to rapidly prototype new ideas and switch between them at different times. So, if I've got something I want to do at a specific moment, I can just add that to this, to both the client and the server, and control both of those things. Each person that connects gets a new slot assigned to them on the server. And we solved the problem of controllers getting lost or damaged. Every phone, so the client actually has controllers on its side. And when you go into something like Pong, the server requests that you open up the Pong controller, which you then can control with your phone. And it gives us unlimited possibilities for interaction. We don't even have to use the screen. We could hook into web APIs like device orientation or web audio. We could create our own little version of like a Wii controller with our phones that are controlled on this screen. This gives us so many possibilities. And furthermore, this reduces the cost of the project. Now I don't even need to take into account controllers. I just have the panels, which we've already established are pretty cheap, and everyone brings their own phone. So it gives us a lot of, possibilities to play with. So, I'm notoriously bad at finishing my projects, but now that I'm comfortable with hardware and I've got a clear path forward for interactions and I've defined these MVPs, it kind of, says to me, building a flip dot display doesn't seem like so much of an unknown to me. Thanks for listening to my presentation. If you're interested in checking out the code for this, I have it up at GitHub. I've also got a small guide as to what you would need to do to get involved in this kind of project. This is the URL. I'll post it in the chat later. Thanks a bunch. Cheers, everyone.